volume in the back. All right, let's go ahead and get started. My name is Darren Nattinger. For those of you that don't know me, hopefully most of y'all do. Y'all aren't going to be clapping after you hear what I have to say. So, I've been working at National Instruments for 17 years.
Oh man!
Old man is correct. I've been in LabVIEW R&D for about 14 and a half of those years. And a few weeks ago, Jim sent me an email asking me nicely to put together a presentation for the CLA Summit, which is kind of short notice. Those of you that know me know that I'm kind of nitpicky about how I put my presentations together, and so I was thinking, oh man, what am I gonna put together? And the idea for this has been rattling around in the back of my head, and Jim motivated me to actually put the presentation together. So today I'm going to be talking about brainless things that we do in LabVIEW. Everybody can still hear me? The mic is acting kind of weird up here, so y'all are good back there? Okay. I don't know what that means.
Put it in the center of your chest.
I am not an AV expert. Okay. Before we get started, y'all don't have to take notes during this presentation because everything is already available online. All you have to write down, or type down as it were, is this URL here, bit.ly VNAT 2016 Brainless LabVIEW. So take a picture of that, write it down, and you can download my slides and go back through all of this stuff later and figure out all the things that you disagree with me on that I'm about to talk about. All right, so I'm talking about brainless LabVIEW programming. If you don't get this now, don't worry, it's at the end too. Now, I'm not saying that you do things that are stupid. That's not what I mean by brainless. What I mean by brainless is things that you do without thinking. There are plenty of things that we do without thinking that are just fine. When you tie your shoes, hopefully you're not thinking too hard about it. When you pour a bowl of cereal, you're not really thinking too hard about that. When you're taking a shower, you're just kind of brainlessly taking a shower. But there's lots of things that you don't want to do in a brainless manner. You don't want to do your taxes in a brainless manner. That will end very badly. You don't want to drive a car in a brainless manner. I have taken defensive driving a number of times over the years, and one of the things that they teach you is you always have to be engaged while you're driving. It's something you do every day, but at the same time you have to be engaged or you might possibly get a ticket once or twice or 10 times. When you buy a house, you don't want to just brainly sign all the paperwork. Unfortunately, there's a ton of paperwork, but at the same time you need to be paying attention, you need to be engaged. There's some things that it's very bad to do in a brainless manner. Well, there's a lot of things in LabVIEW that every single one of us in this room, including myself, do in a brainless manner. And why do we do them that way? Well, there's a lot of things that we've just always done a certain way, and when we encounter that situation in LabVIEw, we just do the same thing we've always done. We've also, as we're all CLAs, we've been taught best practices. We employ best practices in our code. And those are things that when you open a VI and you start writing it, you think about that best practice and you just do it. And I'm here to say that a lot of the times when we do those things, we end up writing inefficient code. We end up writing incorrect code, which is even worse. Sometimes we write code that's hard to read, hard to debug, and the thing that really gets to me, because I'm big on efficiency, you end up writing code that you don't even need. So, in this presentation, I'm going to talk about 8 things that all of us LabVIEW programmers do without thinking, in a brainless manner. And I'm going to propose today that these things are very often the wrong thing to do. Hopefully I've got your attention. Everything that I'm going to say in this presentation, everything mostly, is completely counter to conventional wisdom in LabVIEW. What we all just take for granted is something that we're supposed to do. I would like for everybody to keep an open mind. Please don't get offended because I'm about to tell you that you're doing things wrong. I do all of these things too, so we're all in this together. You ready? Everybody awake? Let's get started. Number 1, every single VI that you write with error in and error out needs a case structure around its contents. Why do we do that? That is something that we all just brainlessly do. Open a VI, drop an error case structure, or open a template and it's probably already there. Why do we do that? Well, there's a few reasons, right? We want to make sure that the sub-VI doesn't execute if there's an incoming error. That's probably makes sense, right? Most of the templates that we have, like class accessors, they already have that in them. That's part of the template. And actually, I assume that this is still the case. When you take the CLD, you actually get minus points if you don't wrap your code in an error case structure. Is that still the case?
Correct.
It should not be the case. Hardly any VI that you write needs an error case structure on this diagram. My esteemed colleague, Stephen Loftus-Mercer, who's sitting over there, brilliant individual. He says a lot of things that I remember because they're smart, and this is one of the things that he said. He said, and I'm paraphrasing because I can't say things as eloquently as he can. He's a computer scientist. I'm not a computer scientist. Anytime you can remove a decision point from your LabVIEW diagram, you are opening up all sorts of compiler optimizations that can take place that otherwise cannot take place if there's a decision that needs to be made on that diagram. Every one of our sub-VIs with an error case structure, there's that decision point that has to be made. So let's get rid of it. When we get rid of it, we can get rid of diagram noise because that's one less thing we have to look at, that case structure. If we're creating a VI from scratch, it takes us less time to write it. That's less, again, efficiency. You don't have to spend as much time drawing that case structure. And so I asked Stephen, why is the error case structure in the class method VI template in the first place? And he actually wanted to provide multiple templates, one with the error case and one without, but still having the error terminals. And basically he got pushback. This is back when classes were being designed. For having yet another option that you have to pick when creating a method VI. So he figured, well, let's leave the case structure there. It's a lot easier to remove that than it is to add one if you want one. In case y'all don't know, I'm the quick drop guy. There's actually a quick drop keyboard shortcut to remove structure. For things that I do lots of times during the day, 2 dozen times, one of those things is removing structures, but keeping the stuff that's inside the structure. And if you pick any structure, multi-frame structure, and press Control-Space, Control-Shift-R, that does the exact same thing as right-click remove structure. And you can press those keys faster than you can navigate the right-click menu. So just a quick little pro tip there. On pretty much every method VI I create, that's the first thing I do. I open this diagram. I guess I could change the template, but I need it sometimes, I guess. But when I don't need it, open the method VI, click the case structure, Control-Space, Control-Shift-R. So keep that in mind. Some other reasons. If you really think about it, this has always kind of bugged me, even before I put this presentation together, thinking about the error case structure on sub-VIs. If you think about it, every single error generated by LabVIEW code, if you're not generating it yourself with G code, is generated by a built-in primitive in LabVIEW. Think about it. I mean, when you dig down, there's going to be a primitive generating that error, or a property node, or a call library node, or something like that. So why are we doing the work of trying to case things out when eventually some primitive is going to be generating the error and all the other primitives are going to be not functioning if they get an input error? I don't think we need to go to the time of trying to take care of that ourselves. Do you really care if your sub-VI runs faster when there's an error condition? Do you really care to skip all that code? If there's an error condition, you're probably not too concerned about performance at that point. Another Stephen quote, you can either optimize the execution of your sub-VI for the case where an error happens, or optimize for the case where an error doesn't happen. Which one of those two things is happening more often? Hopefully, the case where an error doesn't happen. So go ahead and optimize your code for that by removing that case structure. Now, notice the guideline I'm providing is hardly any VIs need error case structures. Some VIs do, and those VIs are the ones where you have written G code that is doing something special with the errors. If you have written G code that's manipulating errors in some way, you do not want to mess that up by having an incoming error screw everything up. And so you can see in this diagram here, we're actually checking for a specific error to see if our database is valid for something. And so we're using the clear errors function with the input that we added a few versions back to tell us if that error happened. Well, if there's an error 8146 coming into this code, then that clear errors is going to think that we have an invalid database when really something happened upstream that's screwing stuff up. So we don't want to mess with our custom error handling in this VI, so we're going to wrap its diagram with an error case structure. This is the time, in my opinion, when it's okay to have an error case structure. All right? That was number one. Does everybody think about that? Yes?
What about creating large arrays?
Creating large arrays?
If you get an input error.
Yeah, so if you've got code that's going to take a long time and you don't want it to run, if there's an error, sure, let's wrap that in an error case structure. Most of the time, I don't think that's the case. Yes?
What about failed application? When you have an error in the CAM, and if you don't wrap it, some of the VI is going to mutate it and say, oh, now the error happened in that VI, and now you have the wrong information. Yeah, so the question is, what if you've got code that's manipulating the values of errors, like if an error comes in and you're translating it maybe to another error? Some code you don't know, you create some stuff on somebody else, you know, an error goes in, and it mutates it to another error and says the error is coming from there. No, it's not coming from there. It's coming from upstream, and now you don't know.
So you need to trust the APIs that you use.
Right.
And if you don't trust the APIs that you use, I suppose you would need to maybe do things to be more careful, like wrapping those things in error cases. One more question, and I got to move on.
Did you do any benchmarking on how much better?
So the question is, how much better performance do you get when you remove these things? Not much, really. I mean, it's a case structure, right? It's skiing off of a Boolean. It's probably not that much. But once you start doing these types of things in tight loops, it's going to be the time when those things, when checking an error condition on sub-VI matters. In your average code, probably not that much. All right, sticking along with the theme of errors. I know people that have the philosophy that you just wire every error terminal on your diagram. Every error output you need to wire. You're either going to be wiring it through your error chain, or you're going to be wiring it to something to like sort of stop the error path, I guess. People do the top one to make sure that there's no possible error you might be missing in your code. People do the bottom one either to signify to the reader of the code that they are not caring about that error, or in my experience more commonly, they want to make sure no auto error handling dialogues pop up, and so they'll either stick a clear errors there or just an empty flat sequence there to make sure those dialogues pop up. Please stop doing these things. Okay? LabVIEW, we love LabVIEW. Jeff K was just talking about how great it is that you can have two loops in parallel and you can just look at the code and know that it's running in parallel. You can have lots of stuff running parallel on your diagrams, and we tend to serialize things with their error cluster if they have an error cluster. But look at that formatted into string up there. There's no possible way that thing could return an error. Now, Stephen might say, you might get a memory is full error. If you get a memory is full error, I don't think you really care that. I don't think you really care that much about the situation you're in regards to error clustering. So if you've got code that can never error out, you don't need to wire the error output. Here's like a delete file function and a close reference function. If you don't care that those things error out, you don't need to wire the error terminal. Now, I hate this feature of LabVIEW. I can say that. I've worked here for forever. I hate automatic error handling. I'm going to start calling it brainless error handling. My colleague Alan Smith would go so far as to say this actually isn't a feature, this is a bug in LabVIEW that needs to be fixed. He says that all the time. And I see code like those top two pictures up there way too often. Now, some people might say, well, that's your way to document the code. You're documenting to the person reading the code that you don't care about that error. I disagree. I think that looks silly. I think that if you don't wire the error output, that's how you're documenting the code that you don't care about the error. So, I'm not going to throw anybody under the bus. So please turn off that feature, the first checkbox that turns on automatic error handling on all new VIs. Please turn off that feature. I hate that feature. Question.
Can you turn it off so it's not default?
I can't turn it off. I tried to get us to turn it off, and people wouldn't listen to it.
What's the INI token? There's an INI.
Yeah, I mean, if you copy over your LabVIEW INI file, then you're good. Most of us, I think, probably do that since we're CLAs, but a lot of people don't, and so that gets enabled. And so you don't think you're writing VIs with that feature turned on, but it's turned on because that tools options checkbox is turned on. Yes, Norm?
Inside of a sub-VI that you create, isn't there a penalty that you can pay if you don't wire it in terms of performance, possibly, if it's in a high-speed loop? So it's copying the default value into that space?
I don't know. Stephen, is there?
I don't know what you're referring to, Norm.
There used to be. There used to be? I know there used to be in some versions. Well, I can't remember what the details were, though. It's been a few years.
There would be if you had a significant amount of data in your error structure. But typically,
Whether it's wired or
All right, so let's assume that there's not a performance penalty. I work on large code bases, and it bugs me whenever a random error pops up because of a situation I don't care about, but auto error handling is turned on. I have a VI analyzer test that will not only detect all VIs in your code base that have this terrible setting enabled, it will also turn it off for you and save your VI. So you can Google test auto error handling enabled. You'll find a VI analyzer test that you can install, and you can optionally turn on the setting that will actually save your code with that option turned off on everything. So please do that, because this feature is terrible, and we shouldn't be using it. Question?
isn't it easier for an INI to uncheck it as a default setting?
Yes, it would be easier for NI to just turn this feature off or remove it completely from the product. Well, no, maybe that wouldn't be easier. But changing the tools option setting would be easier. I have not been able to convince the power to do so. Question?
What about the teams that have different levels of proficiency, and there are developers that are a little bit sloppier and actually are introducing this, and the error is the automatic error handling is the way for them to get reminded?
So the question is, what about a team that has people that don't wire their errors very well, and so there might be some places where they should be handling an error and they don't? Those people need to be taught the right way to code. They don't need to be given crutches to program in LabVIEW without doing any error handling whatsoever. Yes, Alan, I got to move on. Last
My
question.
very specific complaint to that specific comment is that when we do this, we are teaching them to rely on something that shouldn't be there, as opposed to learning how to do it right. This is not something to help make them better in the short term. This is an actual block to their long-term proficiency.
So, if at all possible, I'm pretty sure Alan hates the feature more than I do. Okay, so next thing that we brainlessly do. We've got a piece of code. We want to know how long it's taking. So we wrap it in a 3-frame flat sequence. We drop the tick counts. We do a subtract. And now we have some execution time that we can benchmark. We all do this. It's super easy. We can knock this code out in a few seconds. But we should stop doing that, because when we brainlessly benchmark our code, we get brainless results. First of all, tick count, don't use that anymore. Use the high resolution relative seconds VI. It's been in quick drop in the palettes for several LabVIEWs now. You're going to get a lot better resolution on your timings with that than with tick count. If you wire constants into the code you're trying to benchmark, the code you're trying to benchmark might get constant folded, at which point your benchmarks are completely worthless. If you don't wire the outputs that need to be wired on your benchmark when you're just trying to see how fast the code runs, the code might get optimized out by the compiler. Those results won't make any sense. If you're updating any indicators on the front panel while running your benchmark, that's going to slow things way down. Your benchmarks will be worthless. If you have debugging enabled on the VI that you're trying to benchmark, then there's going to be hooks that the compilers put in for you to be able to separate points and execute and highlight, whatever. That's going to skew your results. If you have any code running in parallel, that's going to skew your results. If you have the panel open of the VI that you're trying to benchmark, that could skew results. Whenever your code runs for the first time, if you're hitting files on disk that haven't been cached by the OS, if you're allocating a lot of memory and the LabVIEW memory manager has to do some work, the first iteration of your benchmark is going to be way off. That can skew things. There might be something specific about your computer that you're using right now that could cause the benchmark you're running to be an outlier. In LabVIEW R&D, we have a grid of 30 machines that we run performance benchmarks on. I'm going to guess most of you guys do not have a similar performance grid. So don't trust the benchmark you get from running that code on your machine by itself for any sort of critical decisions you need to make for your applications. Now, if you just want to get an idea of the execution time of your code, follow all of the rules that I just said before, and that will give you a pretty decent result. So instead of that first picture, you got to do something more like this. Wrap your code that you're benchmarking in a sub-VI, call it in a loop, delete the first iteration's time whenever you take the average, and in that actual sub-VI, use the high resolution relative seconds, turn off debugging, make sure everything that you're passing into the code you want to benchmark is a control and not a constant. Make sure you're actually reading the values being generated by your code. Do all of this stuff to get a more accurate benchmark than you otherwise would get with that brainless 3-frame flat sequence, tick count, done thing that we always do. Question, Jim?
Well, I found wrapping that in like a while loop and running it like over and over and actually plotting the minimum time.
Oh, yeah.
The best performance you'll ever get out of it is a more accurate representation.
So yeah, Jim makes a good point. Do this in a while loop, stick the graph up there, and now you can sort of see a trend of multiple values of benchmarks. Look for the best time. That's going to be a better indicator of sort of maybe the overall execution time of your code. Another question?
Why benchmark like this over using a profile performance?
Yeah, exactly. The whole thing about this is, if I'm talking about like the brainless things that we do. One of them is, I know I do it, 3-frame flat sequence done. How long did it take? If you're really wanting to get accurate values, then you can start talking about using Profiler, the desktop execution trace toolkit. But if you want to do that whole quick and dirty benchmark, put a little thought into it so it's a little less dirty. That's kind of my point I'm trying to make here. One more question, then we'll move on.
You made the quick drop shortcut for that?
Has anybody made a quick drop shortcut for doing the wrapping of the code? I think there was a JKI right-click framework one for it. I don't know if anybody ever ported that over to quick drop or not.
There's one in 15 for right-click menus.
Oh, somebody made a right-click menu plugin for LabVIEW 2015. Excellent. All right, I'm going to move on. Okay, fine, Steven. I won't move on because you have to.
You also need this if you're going to do programmatic benchmarks. Like every night, run it, make sure you're having social performance. That's
Right.
when you can't use the built-in programmatic.
Exactly. Good point. If you need to do programmatic benchmarks, some of those tools like Trace Toolkit and stuff like that, you're going to have to do this instead. All right, I'm going to move on. This one's fun. I swear. How many times have I heard people say to avoid global variables at all costs? They are evil. They lead to race conditions. You can abuse them. Never use them. They're evil. Use functional globals instead. Did I mention they're evil? That's what everybody says. No. No, no, no. Globals are one of the many, many tools that we have in this wonderfully large toolbox we have called LabVIEW. They're very easy to use. They're one of the easiest ways to pass data from one place to another other than a wire. Now, the whole thing about globals is you have the potential to use them in an unsafe manner, right? You might write to them in multiple places and have race conditions. It's possible that your code is going to have some sort of unsafe issue. But the same could be said for driving a car. You can drive a car in an unsafe manner. Does that mean we don't ever drive cars? No, that means we use our brains when we drive cars because cars are an excellent tool for a particular situation. So, safest way to drive a car, wear your seatbelt, observe stoplights, don't speed. Lots of different rules that we follow. Same thing with globals. Write to them in one place or 0 places, and they're great. If you start writing to them in 2 places, yes, you are using globals in an unsafe manner. Use something else. I've seen people who, instead of using globals, they make a functional global with read and write as the values in the enum. That's exactly the same as a global, you just took longer to make that thing. It functions identically. So if you're in the situation where you want to do a read and write and you're writing to it in 1 or fewer places, just use a global. Now there's a trick, if you don't know this trick, ask me, ask Fabiola, ask Steven, ask anybody that's on Lava. There's a trick we can do where you take the global, you make it private in a library, you take a VI that writes to the global, you make it private in the library. And that way you can have anybody read from that global all over your code, but nobody can write to that global except for you, the designer of the library. So it's a trick you can use if you want to use globals, but you're paranoid about people writing to them in multiple places and giving them race conditions. So I like global variables. I wrote a blog post about this a long time ago. The guy watching the train wreck is the icon that I have on that page. So you can go read LabVIEW Artisan Globals and check out my blog post and see what everybody has to say. A surprising number of people agreed with me and didn't unfollow my blog as a result of me writing this post. So I was happy about that. All right. Method VIs need pass-through class wires. Now, in this part of the discussion, I'm going to be talking about classes that are by value classes. So I'm not talking about a class that only has references in its private data. This is a class that has, regular old data in it. And we all write code that looks like this. We write code that takes a class in, does a bunch of stuff with it, outputs a class. We really like train tracks in LabVIEW, don't we? We really like train tracks. We really like a class on the top, error on the bottom. We see that and we're like, that's something familiar. I like the way that looks. It makes me happy. It's like seeing a sunset or a nice view of a beach in Hawaii. We like to see this. I now hate to see train tracks with class method VIs. I'm going to tell you why. If your class method VI does not modify the data in the class, please don't put a class output on that class method VI. For one thing, you lose the parallel execution benefit that you often have, where you can have VIs running in parallel as opposed to in a train track. One person told me one time when I suggested this, they said, but then you can't have a dynamic dispatch on that VI. That's not true. You can have a dynamic dispatch input on a method VI with no class output on that method VI. That's perfectly fine. LabVIEW likes that just fine. The number one reason I'm suggesting this, though, as I will show in the next slide, is that I have spent a lot of time debugging class-based applications. And what ends up happening is that something gets messed up in my class data. Like I've set a probe somewhere further down the chain. I'm looking at the class data in the probe, and there's a value that I'm not expecting in there. So now I need to sort of go back through and see, well, where are the places where that value could have been messed up in that class? Every method VI that I see a class input and a class output wired is a potential place where that class value got modified. And it has taken me a long time to debug those applications to finally find a place where that class data actually got modified in an incorrect way. So, prepare yourselves. I want you to start writing code that looks like the top picture and not the bottom picture. The reason I want you to write code like this is because if I'm debugging this application and I need to figure out where my class data got messed up, in the bottom picture there are 6 sub-VIs, and not even sub-VIs, sub-VI hierarchies, because there's going to be lots of sub-VIs that those guys are probably calling. 6 possible sub-VI hierarchies I have to start digging through to check and see where my class data got messed up. In the top picture, there are only 2 sub-VI hierarchies that I need to dig into to try and figure out where my class data got messed up. Because all those other VIs that are not passing a class output wire, there's no possible way for them to mess up my class. Now, we could spend the rest of my 50 minutes talking about this, but there's actually a lot of discussion on this topic that's already taken place on a blog post by the fine folks at Delacorp. If you Google LabVIEW just passing through, we have a discussion where we talk about all that stuff. Babe, your hair is long. What's your question?
I don't know how to go so for a long time. It used to be that if you didn't use the magic pattern, you caught a single copy of a cluster, you caught the whole cluster.
Right, so there's the whole thing about how not passing the class in or the class out or the cluster in and the cluster out, you might make a copy of the data. We talk about that on the Delacorp blog post, but we're good. LabVIEW compiler knows what it's doing, doesn't make the extra copy. I'm not with the suggestion of the top picture there, y'all's code is not going to slow down. Y'all's code is not going to allocate a bunch of extra memory. We're good. Jim?
You guys talk about the what if somebody modifies the method so that it does modify?
Yeah, so that comes up in the Delacorp blog post as well. What if your method VI does end up starting to modify the class data? Well, your method VI should not have a class output on its connector pane when it doesn't modify the data. If it does modify the data, you are now adding a class output on the connector pane, and you are modifying callers appropriately. So there's never any code that assumes, with this approach, there's never any code that assumes that it's modifying the class data when it's really not.
What would be the best practice for notifying the callers of your API when it sounds like? Because it seems like that should be like a flag that alerts them that now they need to go into their code and change it, and it might not just be my application, it's a whole suite of users.
So Jim's point is there any way to sort of notify the callers of a VI that previously did not modify the class data? If they did, that would be an awesome thing to have in the editor. We don't have anything like that in the editor right now. My approach would be to basically find the callers and then make the modifications appropriately. In my experience, having to take a method VI that did not previously modify class data but now is modifying class data is extremely rare. Alan?
VI analyzer test.
You could also write a VI analyzer test.
Go through and look for unwired class outputs.
Yep.
Because you either shouldn't have them, the class output shouldn't be there, or you should be wired through.
Right. One more question, John, then we'll move on.
We need a required output then.
Yeah, so everybody wants a required output on sub-VIs. I agree, that would be great. We don't have that right now. So that would be a great solution. I'm going to move on, David. So.
I was just going to say change the name and get rid of your old method.
Okay, so yeah, I guess you could deprecate the method. That's one other approach. Again, this does not happen to me very often in my experience, so hopefully it's not something you're running into all the time. So, one more thing. So, in this particular API, this is the installer builder API, in case anybody's curious, the way to programmatically call install builder. Those 6 VIs have to be called serially. There's just some stuff that needs to happen under the hood. That's why the error wires is there. We're calling this guy serially. If you didn't have to call your class VIs serially, you could write code that looks like this top picture here. So now we're taking advantage of LabVIEW's parallel execution because we have now figured out which method VIs don't modify the data and they can run in parallel with one another. So if your VIs don't have to run serially and you get rid of the class outputs on your VIs that don't modify class data, your code looks like the top picture, which is completely different than what we're used to seeing, which is the train tracks below. But it's going to run more efficiently and it's going to hopefully be easier to debug. That's my story and I'm sticking with it. All right. Number 6. You must close all references in your LabVIEW code. If you get a reference, close it when you're done. It's a commonly accepted best practice. We all brainlessly drop close reference whenever we're done. And it's the easiest way to avoid memory leaks in LabVIEW. No, do not close all your references. See, I told you guys I was going to be saying things that you're going to, like, we should have handed out tomatoes or something. I hate tomatoes, so that would have been a great thing to throw. All right, so there are some references you always want to close, no question. You want to close ActiveX references, .NET references, hardware references. You guys know this. You want to close application and VI references that you're explicitly opening, like with the primitives or with the property node that returns them. You want to close references to anything in the project item API, if you're scripting projects. You want to close a reference to a project. These are all things you definitely do want to close. But there are lots of references you totally don't need to close. You ready for this? All right. Anything in VI Server that inherits from GObjects. So if you're writing scripting code or parsing panels for stuff, you do not have to close anything that inherits from GObject. Look at that top picture. Isn't that insane? You read a panel reference, you close the panel reference, then you use that same panel reference and it totally works just fine. That's because close reference is a no-op on GObject. So all you're doing is wasting time and wasting diagram space every time you drop a close reference for anything that inherits from the GObject class. And that includes control references. Hopefully you guys know this, but I have seen people close control references when they're done. Completely worthless. You're wasting your time. If you use the this VI and this application static references, you don't have to close those. Anytime you use an implicit property node that isn't wired to the app or the VI, hopefully everybody knows you can do that. It's actually a pretty handy technique to get a reference to this app or this VI. You don't have to close those when you're done. So several references, and again, this is all about using our brains while we're writing our code. We're going to save time without doing those brainless things, like, in this case, closing GObject references. So you heard it here first. Charles.
Why don't you just change the compiler to make that a broken wire if you go to anything that inherits from GObject?
Charles just asked me why I don't just change the compiler.
You as an I.
I'm just one of you guys, okay? No, I'm sure there's stuff that could be done. Prioritizing the lack of need to close GObject references isn't exactly something that's going high up on the list. Yes?
Does that include GObject references that are inherited, that are found from references to other VIs or other application instances?
So the question is, does that include GObject references that you have obtained by, like, say, traversing another VI that's open? All GObject references. Don't worry about it. Save yourself some time. Don't close them. All you're doing is no ops in the LabVIEW compiler. It might actually be laughing at you. Like, there might actually be a function in the compiler that does a little chuckle whenever it sees somebody close the GObject reference. One more question, then I'm going to move on.
Does this include long-running VIs?
Does this include long-running VIs? So there was a bug many releases in LabVIEW ago where you could, like, read the panel reference in a loop and you would get a different reference each time it ran, and then you would have a memory leak. That stuff's been fixed for a long time.
Yeah.
One more question.
Yeah, what version?
Oh, like 7, 8. It's been a really long time. 9, 10. It's been fixed for a long time. All right, so I'm going to move on. So this is one of those, this is how I've always done the type of things, and I fall into this trap too. I actually fell into this trap during the middle of a presentation at a CLD summit last year where I was writing some code and I totally did this. So this is some code from one of my VI analyzer tests. It's one of those whole things with scripting where you've got like a whole bunch of nested stuff going on. If this happens, and if this happens, and if this happens, and if this happens, and if this happens, then go ahead and do this thing. And that's what this code is doing. We're basically getting to that very well-nested part over there where we finally found an object that we care about. And we're using build array inside of a case structure to then add that item to the array. We've got the shift register that has the array of things that we've been keeping track of. We've got 1, 2, 3, 4, 5 case structures where we've had to pass the array wire through, and we don't have to write code like this anymore. This is one of those really wonderful places where you can be lazy and your code is more readable and easier to maintain. That doesn't happen very often, so it's pretty cool when that happens. This is one of those cases. So you can see I wiped out that shift register, I wiped out that wire that I had passed through everything, and I'm using a conditional tunnel. So conditional tunnels we added in 2012, 2013, somewhere around there. And as you can see, all I have to do is just wire that thing that I want to build into an array straight out from the most nested part of my code and just use conditional tunnels to say whether or not I care about this item that I'm adding to the array. And Steven says that in 2013 and later, this is actually more efficient than using the build array inside of the while loop. There's probably like reasons I don't understand for why that is, but I trust him. So I'm being lazier. I've got code that's more efficient. I'm spending less time passing those wires through all those case structures. That's like a win-win-win-win, I think. So hopefully, and again, this is one of those old patterns that any of us that have been programming LabVIEW for forever, we do that all the time just without thinking, passing the wires through. But now stop and think about it. Oh yeah, I can save myself like 10 wires and a couple shift registers. Jeff?
Don't you need a conditional tunnel on for loop as well?
So the way this works is that the inner for loop has a stop on it. And so we're stopping the inner for loop once we find the thing we're looking for, and then we conditionally build them out there. All right, number 8.
Does this use more brain, though?
Does this use more brain? Yeah, you're having to use your brain to say, oh, wait a minute, I don't have to write the code like I always did. Let me write this new, lazy, fast way. Right? Okay? All right, you guys. Y'all knew this was coming. Anybody that knows me knew that this is coming. All 6 of these quotes are things people have actually told me when I try to convince them that they need to start using QuickDrop. I'm the QuickDrop guy. I added QuickDrop in LabVIEW 8.6. I have been relentless in the past 8 years in my attempts to convince people to program with QuickDrop. But these are things people tell me when they don't want to use QuickDrop. These are excuses that people give me. They say, come on, I'm already fast enough with the palettes. I've got muscle memory from a decade of LabVIEW programming or more where I know exactly where everything is in the palettes. I right click, I just know where the thing is. I don't know anything about it.
Especially since last season, I never moved the furniture around on the pallets.
Oh, yeah.
So you guys can complain about the pallets all you want, and those complaints mean nothing to me because I hate the pallets more than any of you. So I've been using the pallets for so long, it would take me way too long to learn another way to program in LabVIEW. I don't know the name of the thing I want to drop, I just know where it is in the pallets. Really, you don't know what a while loop's called? And this one I like. LabVIEW is a graphical programming language. Why am I typing on my keyboard to create my diagram? and then there's the people that are like, well, you know, QuickDraw's pretty cool, and I want to use the object shortcuts like CS for case structure or WS for while loop, like the little quick keyboard combos. And I have to go download your plugins, or I have to go add them myself, and that's a pain to be able to add the shortcuts. No. We're all engineers, so we like numbers. So I've decided I would stop using the whole, like, I promise you'll be faster if you use QuickDrop without having any numbers behind it. So I am the 7-time undefeated, retired, world's fastest LabVIEW programmer. I use QuickDrop when I program in LabVIEW every single day, but in LabVIEW 8.5 and earlier, I had to use the palettes because I didn't have another option. And I've got a pretty good memory. I remember where stuff is in the palettes, and so I recorded myself programming things with the palettes and with QuickDrop, and I went back and I timed how long it would take me to drop objects. So the thing about the palettes is that you can have things that are deeply nested. Like if you want TCP read, functions, programming, data communications, protocols, TCP read. That takes a long time to get to compared to something like a while loop. Functions, programming, structures, while loop is the first one, I think. So I averaged the time it took me to drop a lot of different objects with palettes. And on average, it took about 2 seconds. Less for some of those less nested things, more for some of those more nested things. The thing about QuickDrop is there's no nesting. You just type a name. If you type while loop, it's the same time as it takes to do TCP read. There's no nesting involved. On average, it took me about 2 seconds to drop an object from the palettes when I knew exactly where that thing was. If I didn't know where it was, then I didn't count those. With QuickDrop, it takes 1/4 of a second, on average, to drop an object. Now, a lot of the times, that's because I'm using an object shortcut. So CS, just 2 characters for case structure. Or RN, just 2 characters for property name. But on average, I can drop an object 8 times faster with QuickDrop than I can with the palettes. There's no arguing with that. The QuickDrop is way, way faster than the palettes. So then I thought, okay, well that's just dropping objects, you know, that's not actually writing VI. So I figured, let me write the random number strip chart that we all know of. So, where's my mark? So it took me about 18 seconds, and again, this was several tries, average, how did I do? 18 seconds to create a random number strip chart. It only took me about 10 seconds to create random number strip chart with QuickDrop. Why is there that discrepancy? Well, there's 4 objects you have to drop when you make that VI. The chart, the random number, the while loop, and the wait. And 4 objects from my previous data takes about 8 seconds to drop to the pallets, just cumulatively if you just take the drop time. 4 objects with quick drop takes about 1 second. So that is undeniable time savings, even when you know exactly where the things are in the pallets, by using quick drop over the pallets. Now, one of the things that is essential to be fast with quick drop is object shortcuts. If you're having to type the full name or at least enough of the name to autocomplete, you're going to be slower than if you use object shortcuts. And here I'm talking about, you can see in the screenshot, CS gives you case structure, CSC gives you class specifier constant. There's about 100 of these things. The thing is that you would have to go download my shortcuts or make your own list of shortcuts if you wanted to use this feature prior to LabVIEW 2016. In LabVIEW 2016, we're going to be installing a default set of object shortcuts. So now you have absolutely zero excuse to continue brainlessly using the pallets when I've given you this feature for 8 years, and in LabVIEW 2016, I'm going to give you the part that makes you even faster using this feature. If you still need motivation, I have quick drop mouse pads. Okay? I have a bunch of quick drop mouse pads, but there is a condition. I remember back in LabVIEW 6.1 timeframe when the auto tool came out. I love the auto tool. There are people that don't love the auto tool. That's fine. But when the auto tool came out, we would challenge people. This is a new thing. You got to use it for a period of time. Use the auto tool for like a week and see if it makes you a faster LabVIEW programmer. Some people said, no way, I still hate it. And that's fine. Some people said, oh wow, this actually does make me faster when they started using it. I'm not dissing on auto tool because I know several brilliant LabVIEW programmers who don't use the auto tool. That's fine. But I'm going to take a similar approach with quick drop. If you can find me during the CLA Summit, of course I'll be around, come see me and come promise me that you will use only quick drop for a week. If you'll only use quick drop for a week, I'll give you a quick drop mouse pad. If you already use quick drop, I'm not giving you a mouse pad. Actually, I probably will if you ask me nicely.
But we don't need a mouse pad anymore.
You know, people say, well, I don't need a mouse pad. These tables, these plastic tables, I find my mouse doesn't work that well on it.
You're not a bad mouse.
That could very well be the case. Like if I'm presenting at a conference, a lot of times they'll have, like at NI Week, they put those fabric things on the tables. Can't use a mouse on that thing. I always keep a mouse pad in my backpack. Plus, the quick drop mouse pad tells you all of the object shortcuts you can use, or all of the keyboard shortcuts you can use while using quick drop. So,
did you sell cars before working for
So Dimitri wants to know if I was a car salesman. I am actually a terrible salesman. It just so happens that I am incredibly passionate about quick drop, and I want everybody in this room to start using it through any means necessary, including shameless handouts. So yeah, find me during the summit. I'll give you a mouse pad. Start using quick drop. Stop using the pallets brainlessly. I know programmers who are really good at quick drop, and I'll still see them right-click and go find stuff in the pallets just because it's been a habit they've had for so long. So break that habit, break that brainless pallet use. Start using quick drop. And hey, everybody, I am done. So thanks for coming. Yeah.
Is it going to be based on your shortcuts?
Yeah, so the question is, what are those default shortcuts that are going to be in LabVIEW 2016? Yes, those are my shortcuts, tweaked a little bit based on feedback from the community. And if you already have your own shortcuts and you copy over your LabVIEW INI file, which most of us do, I'm not going to mess with your existing shortcuts. Yeah. Another question?
Is there a way to discover those shortcuts?
So the question is, how do you find out what the shortcuts are?
Well, yeah, I know you can just like look in the list, but
yeah, look at the list. What's wrong with looking at the list? They're right there. Go look at the list. David.
This actually from your first slide and one later on. You said trust your APIs.
Yes.
VI.live and NISHITS is my API.
Mm-hmm.
So regarding case structure outside my VI, I don't do either. It's fair. But I have a challenge in that every single function I've called might be standard error in, might not be standard error in. I have to dig into the help file to figure out whether that does.
Yes.
I need that to be immediately apparent on the editor, where it's tough for me to know what to wrap, what not to, what
absolutely
functions on, stuff like that. That's true for errors and also for for your closing references, like I don't know which one's closing which one. I don't want to have to memorize that and the teacher only because it's nuts. So if you guys can make it more immediately apparent in the editor when I do a thing and when I don't do a thing.
So the feedback is, to summarize, it would be great if instead of having to know which VI-lib VIs can have standard error functionality versus not, which references you have to close, which ones you don't. It would be great if the LabVIEW editor gave you clues about those things. I 100% agree. Those would be great features for us to have in a future version of the product. Another question? Back. So the question is, have I ever had like carpal tunnel or any hand issues with quick drop? I have not. I'm pretty sure it's because I've been playing the piano since I was the age of 6. So my wrists are very strong. That's my only guess. But I haven't, and you know, I use the ergonomic stuff like the little, you know, rubber thing in front of my keyboard and all that kind of stuff. No, I've not had any hand issues or anything. Another question.
Is there a document online that lists the rationale for the shortcuts that you selected, those object shortcuts?
Oh yeah.
Just because that helps me learn them is why did he pick these letters for this thing?
Yeah, so the question is, how do we pick the shortcuts for quick drop? I can give you sort of a summary. Most of us program LabVIEW with our right hand on the mouse and our left hand on the keyboard. Some people don't. I think, Damien, you don't, right? So yeah, Damien mouses or trackballs with his left hand. But most of us, right hand on the mouse, left hand on the keyboard. And the way to be fast in quick drop is to not have to do that context switch all the time of moving your mouse hand over to your keyboard. It's great if you can write your LabVIEW program using quick drop while your left hand stays on the keyboard. So almost all of the object shortcuts in quick drop you can type with only your left hand. That's why for something like a property node, I didn't do PN for that because then your hand has to jump all the way over here. I did RN. So there's several that's kind of the rationale. If you want to read about the specific reasons we decided certain things, some of that is discussed on the Quick Drop community. If you guys go to ni.com/quickdrop, yes, I found out the person at NI that can give me short URLs. It's awesome. So ni.com/quickdrop, that takes you to our community page. And one of the very recent our threads there is us discussing these default shortcuts that we included in the product. Right at about 9:50. Any last question before I shut down? All right, thanks everybody.